Hi everyone, welcome to my Maths GCSE video. We're going to look at histograms. So histograms is quite a tricky topic on the GCSE course, especially because people get a bit confused between histograms and bar charts. So in a bar chart, what you've got is bars going up, okay, all the same width, and what happens is however far up here, that tells you how many it represents. Now in today's little video, when I say how many, I'm going to be using the word frequency. Okay, so frequency is how many of it you've got basically. So maybe this is up to 4, maybe this is up to 7, this up to 9, I don't know, something like that. So that's a bar chart. A histogram isn't like that. For a histogram, the bars can be any width. Okay, so you could have one bar quite long like that, and you could have one bar quite thin. Okay, and because they're different widths, it's not good enough to just say how high they are. What you look for in a bar chart for how many is the height. What you look for in a histogram for how many is actually the area occupied. Okay, so in a histogram, a frequency is the area. Okay, so you find the area to tell you how many. So that means that it can't be frequency that goes up the side. Here it's frequency. Here it's something else, and we call it frequency density. Okay, and then going along the side is whatever you're talking about. It could be time, could be height, whatever. Okay, but what we usually focus on is how wide this is. So this is called the width. So if we imagine that we've got one of our bars on a histogram, that's terrible. Let's do it again. One of our bars on a histogram. If we want to know the frequency, what we want to know is how wide it is, okay, which we call the width or the class width, okay, and we want to know the height, which is actually called the frequency density, or FD. Okay, so that gives us a formula because we know how to find the area. The area of a rectangle is base times height. And all I would do if I was you going into your exam is remember this diagram, how it works. Because from that you can think, well, area is class width times frequency density. So that gives us a special formula for the histogram. Frequency is frequency density times by class width, which we could call CW. Okay, so that's the formula that you need to know, you need to learn, or like I said, just remember the diagram above. So let's try some actual questions from GCSE papers and see what we can do, because I think the best way to learn is seeing questions done, doing questions yourself. Some of this writing might be a little bit small, but I've had to scale it down to fit everything on. I'll be reading it as well and trying to write out again important bits. Okay, so the incomplete histogram and table gives some of the information about time in minutes that cars were parked in a car park. Like I promised you, frequency density going up the side, and then something else, measurement going across, in this case time. So what we have to do is use the information in the histogram to complete the frequency table, and use the information in the table to complete the histogram. This is a very, very standard question. Okay, so let's look at our table and think that's quite a bit of information. We've got the frequency and we've got the width. Now what do I mean by we've got the width? I mean that we're told that this bar goes between 30 and 40 on the scale, because it says T is between 30 and 40. So this is a rectangle that we're talking about. Okay, and the area is 35. because the frequency is represented by the area. Okay, remember the formula? Frequency equals frequency density times class width. So that means that we can figure out, and I'd always, by the way, recommend an extra column here for class width, how wide it is. Don't panic about this. All it means is from 0 to 30, how wide is it? Well, it's 30. From 30 to 40, how wide is it? 10. Okay, because there's 10 to go from 30 to 40. From 40 to 60, 20. From 60 to 80, it's going to be 20. From 80 to 120, it's going to be 40. Okay, so we've got the class widths. And a nice other column to think about is frequency density. And then if you put those columns next to each other, all you can do is you can multiply and get the frequency, which is perfectly in line with the columns. Okay, so I think that's definitely the best way to do it. So that means that we can figure out a couple of mystery numbers straight off. We can figure these out. Okay, that's because for the first one, 10 times something is 35. So 10 times something is 35. Well, it's going to be 3.5 with a bit of thought about what happens when you times by 10. So that means that we can look at our table. I'm going to kind of do everything in the same go here. And we can think, don't want to do that. We can think, okay, well this bar that we're talking about goes up to 3.5. So we can figure out a scale. Let's see how it hops up. It goes 1 block, 2 blocks, 3, 4, 5. I've done that wrong. 5, 6, 7. Okay, so with a bit of thinking, that might have gone one too far there. 2, 4, 5. Sorry about this. I've shrunk it down so even I can't see what's going on. Okay, with a bit of thought, from 0, how much do you have to step up by? You have to step up by 0.5 each time so that you get to 3.5 correctly. So the last one is going to be 4. Okay, that's all about figuring out scales there. So next one is, the next one we're going to figure out is this value, which is 20 times something gives you 30. Well, 30 is 1.5 times 20, so that's 1.5. Okay, and the last one, 40 times something, for here, gives you 20. Well, that's half of it, isn't it? 0.5. So, for the rest of the table, we need to use the diagram for. So, for the first column, for the first bar, it goes across 30, and we want to know how far it goes up. Well, fortunately, we've cracked the code. We've found out the scale. So we know it goes 1 up. So that means 3 times 1 gives you 30 for the frequency. For the next one that we don't know, 40 to 60 is here. It's this bar. We know our scale, so we read across, and the frequency density is 3. 20 times 3 is going to give you 60. We've filled in the whole table. Let's carry on with this question to fill in the rest of the histogram. Okay, so 30 is done for you. That next one done, next one. The one we're up to is 60 to 80 here. So 60 to 80, let's do what it told us to. And how far do we go up? We go up to the frequency density, which is 1.5. Okay, and guess what? If you do 20 times 1.5, you get what you want, that 30 people are in this area. Next one, 40 is the class width. Goes from 80 to 120 all the way across there. Goes up to 0.5. So that's your last one. And that is the question done. I know it's quite tricky. It is grade A or A star. Okay, so it's difficult work. Next one. A call center receives 64 calls one morning. The table gives information about the length in minutes of these telephone calls. What did I tell you about the extra columns? Let's whack in a class width and let's whack in a frequency density, because then we can multiply the two and get the answer of frequency. So class width 0 to 5 is 5, 5 to 15 is 10, 15 to 30 is 15, 30 to 40 is 10, 40 to 45 is 5. Okay. We need the frequency density, so we need to know what to multiply 5 by to get 4. This one could be on a calculator paper, I suppose. So let's think 5 times something gives you 4, or it might not be because you have to do 4 divided by 5. Let's pretend it isn't. To divide by 5, my top tip, you can divide by 10 and times it by 2, because 10 divided by 2 is 5. So if you're doing the opposite, divide by 10 times by 2, same as divide by 5. So 4 divided by 10 is 0.4, times by 2, 0.8, and you might have thought, okay, as a fraction, 4 over 5 is 0.8. Same thing. So that's in there, 0.8. Next one, it's 10 wide and we want to get it to 10, so we only times by 1. The next one is 15 and we want to times by something to get 24. Focus of this video is not the math skills, as in number skills, so I'm just going to use a calculator. 24 divided by 15 is 1.6. This one is 10, we've got to get to 20, we can do that as 2. Next one is 5 and we have to get to 6, so do 6 divided by 5. You could do the same trick I taught you before and you get 1.2. So now we know how far up we have to go. Okay, and our biggest value is here, 1.6 up. So this is our frequency density that we plot. And the frequency comes out as the area, remember? So it's starting on 0. We've got 1, 2. These squares always trick me here now. 5. Just going up 5 at a time to think about scale. 1, 2, 3, 4, 5. Okay, so that's just giving us some notches, going up 5 at a time. Now we think about what number to allocate to each of these. So let's imagine we go up here for 1. How's that going to work out? That means that this would be 0.5, this would be 1.5, and the biggest value we want is 0.6. That actually means that each little notch is 0.1. No, it doesn't. It means that 2 little notches is 0.1. Okay. So I reckon that's the best scale to go for. Just destroying everything now. 0.1, 0.2, 0.3, 0.4, 0.5, 1. Okay, so we decided that 2 little squares is 0.1. You can make your own decision about that. So that means that that is 1.6. And our first value to plot is from 0 to 5. So you go across to 5. And you go up to your frequency density of 0.8. Remember the scale we organised? So it's going to be 0.5, 0.6, 0.7, 0.8. There we are. Draw it in, and you can shade it or whatever you want to do. Okay, that's our first bar drawn. And the area, if you do 5 times 0.8, you're going to get 4, which represents how many? Next one, it goes from 5 to 15. So from 5 to 15, that's how wide it's going to be. And you need to think about the height. The height is 1, so you go up to 1 here. That's your next bar. Okay, just a bit of shading. Next one is going to go from 15 to 30, all the way across to 30. So that is your width. And we need to think about how far up to go. This is our big one, up to 1.6. So all the way up to 1.6 and across to 30. Is that done? Next one, 30 to 40. So from 30 to 40, and we go up to, you're kidding me, I didn't even notice we had to, bet you were all shouting at the screen. But guess what? We got lucky because that's going to be 2. So everything worked out okay in the end. There you go. Next one is 1.2. So it goes from 40 to 50. No, it doesn't. I'm lying to you. It goes from 40 to 45. So don't assume that it always goes to the end. It goes up to 1.2. So 1.1, 1.2 is here. That completes our diagram. Okay, so that is your histogram. And each of the areas is going to represent how many you've got in each class. Okay, I hope that one made some sense, and do apologise about missing the 2 there. Must have seen it as a 0.2. Next one. The incomplete histogram and table shows information about weights of some containers. Okay, so we've got big numbers here, 0 to 1,000. If you haven't got space, you can do class width and frequency density in a column of your own. So class width, frequency density. Class width from 0 to 1,000 is going to be 1,000. From 1,000 to 2,000, 1,000. 2,000 to 4,000, 2,000. 4,000 to 6,000, 2,000. 6,000 to 8,000, 2,000. 8,000 to 12,000, 4,000. Right. Oh, big numbers. Frequency density. What do you have to times 1,000 by to get 16? So you can do 16 divided by 1,000. You can move your zeros, or you can use a calculator, because like I've said, we're practicing histograms here. 0.016 for the first one. The next one, we haven't got the info for frequency yet. This one we do, the 4,000 to 6,000 interval. We're going to do 16 divided by 2,000 to give you 0.0. Let me think how many across. 1, 2, 3. 0.008. Okay, that's fine. Next one we've got is here, which is going to be 8 divided by 4,000, which gives you 0.002. Okay. Next one. 0.002, is that right? I think so, yeah. Now we need to look at our table. We need to think about the scale. So the first one we've got all the info for. So let's look at that one. It's 1,000 across, and it goes up to 0.016. 0.016. What a horrible number. So half of that, how many have we got? Half of that, 1, 2, 3, 4, 5, 6, 7, 8. It's 4. 1, 2, 3, 4. That's half, which is 0.008, which means that half of that, 0.004. Do you see how I'm figuring out the scale? 0.002, 0.06, etc., etc., etc. 1, 2. Zero, just to have continuity. If we carry on going up, 0.018, 0.020. Right, so we've got a scale drawn on. For the second one, it goes up to 0.018, so we can think about that as here. And how we set this up, remember, we just multiplied that by 1,000 to get 18. Next one is going to be 0.1, 0.01, sorry. And so we do 2000 times 0.01 to get 200. Did I get the last one right, I think? Yeah. Okay, and next one here goes up to 0.006. And this is 6,000 to 8,001. 0.006. So we multiply that by 2,000. 12. I'm thinking that must be wrong. 0.01. 20, not 200. I thought something had gone wrong because that 200 just looked too big there. Sorry about the mistake. Right, let's get it drawn on. So it always says complete the table, complete a histogram. Okay, that's basically what you're going to have to do. So looking at our fourth group, 4,000 to 6,000. So it's here, and we want to go up to 0.008. So we draw it in, give it a bit of shading. Next one that's missing, 8,000 to 12,000. It's going to go there, and it goes up only to 0.002, which you can see here. So we draw it in. That's the histogram complete. Okay, next one. Incomplete histogram again. Table to give some information about distances that some teachers travelled to school. Use the information to complete the frequency density table. Okay. Right. So distance, remember we want, this looks familiar. Class width, frequency, and we need a frequency density somewhere as well. Let's do it on the side because there's not much space there. Class width, frequency density. So the width of the first one, 0 to 5 is 5, 5 to 10 is 5, 10 to 20 is 10, 20 to 40 is 20, 40 to 60 is 20. We haven't done this already, have we? The numbers just look very familiar. Oh well. Okay, carrying on then. So, frequency density, it's 5 times something to give you 15. It's going to be 3. 5 is a nice number. Times something to give you 20. It's 4. 10 times something, that one's missing. 20 times something to give you 10. It's 0.5. And now the rest of it we can use the table to help us. So we can figure out our scale. So if this first one has a frequency density of 3 from 0 to 5, then this is 3. Okay, so let's put in our notches as I did before. These lines are crazy. Okay, so how many notches we got? 1, 2, 3, 4, 5, 6. So you miss one out each time. And it's decimals. 1.5, 2.5. Carry on. 3.5, 4, 4.5, up to 5. Okay, so now that we've got that drawn on, we can think about our class that's between 10 and 20. So between 10 and 20, we know it goes to 2.5 here. 10 times 2.5 is 25. Okay, next one between 20 and 40 goes up to, ooh, dodgy. Each little square is 0.1, so that's 0.8. Goes up to 0.8. 20 times 0.8. 16. And we've completed the table. Okay, using this information to complete the histogram from 40 to 60. There's only one last bar to draw. Goes up to 0.5. So it's just literally there. Okay, so this is the distance in kilometers. Apparently no teachers travel more than 60 kilometers to get to their place of work. Okay, next one. So, histogram, we're not given a table on this one. Okay, fair enough. Tom asked the students in his class how many hours they watched TV for last week. The incomplete histogram was drawn using results. 8 students watched TV for between 10 and 15 hours. So between 10 and 15, let's put an 8 in the middle. Let me try and make that stand out. 8 people. 6 students watched TV between 0 and 10 hours. No students watched TV for more than 30 minutes. Okay. And work out how many students Tom asked in total. So this is a nice way to ask it, because what we have to do is we have to work out the scale for frequency density. Then we have to draw on the bar for here between 0 and 10. And then we have to add up all the people. Okay, so you'll see what I mean when I show you. At least this is a bit of a different question, so that's nice. So let's think that this one is 5. So we need to figure out, I'll take this to the side to be fair, so it doesn't get in the way of our diagram. So we take our rectangle to the side, we know it's 5 wide, we know the area is 8, okay, and what we want to know is how high up it goes, because that would be our frequency density. So 5 times something gives you 8. Well, we can do 8 divided by 5 to figure that out, and it is 1.6. Okay, so that is 1.6. So the frequency density going from across here is 1.6. Okay, let's see how many notches we've got going on. Not a very technical term, I know, but hopefully this is literally just how I would do it, to be honest. Put the notches in and think, how many have we got? 1, 2, 3, 4, 5, 6, 7, 8. So that means that each notch is going to be 0.2, because 0.2 times 8 is 1.6. You can always try it out with a pencil and rub it out if this bit goes wrong. It's not a problem. 1.8, 2, 2.2. Okay. So we want to represent between 0 and 10 people. Now let me just draw this randomly. We know it's 10 wide. Okay. We know that it's 6 students. So we have to go up by 0.6, because 0.6 times 10 is 6. Okay, so that has to be 0.6. Does that make sense? It's all about the area thing. So we draw that on as 0.6. That's representing 6 people. So 6 people there, 8 people here. The next one that we're talking about, between 15 and 10, goes up to 1.2. So it's 1.2 up, and it's 5 across. So the area is going to be 5 times 1.2 is going to be 6 again. So that means, if you're very astute, that the area of this thing is the same as the area of that, because they both represent 6 people. Anyway, next one goes between 20 and 30. So it's 10 wide. Let's take it off to the side to show you this last one nice and clearly. It's 10 wide. We know that it's 0.5 up. It's halfway between 0.4 and 0.6. So you're going to do, for the area, 0.5 times by 10, which is 5. So there's 5 people in this one. So you add up how many you've got in total. You've got 6 plus 8 plus 6 plus 5. Okay, so it's going to be 25 people. So we completed the histogram. We found out how many people. So I like that question. I think that's a nice one. Okay, so this is the last question that I'm going to look at with you. It's in 2 parts. Table and histogram show information about the length of time it took 165 adults to connect to the internet. Okay, so I assume these are going to be in seconds, otherwise that would be a bit worrying. So I'll draw these bars on. They're already there, but not very clear. So this is the info that we've already got. Okay, so we've got the table again, but this time we need to draw on class width. There's not really much room there, so let's go over here. Class width and frequency density. And remember that class width times frequency density gives you the frequency. So the class width for the first one from 0 to 10 is going to be 10. From 10 to 15 is 5. From 15 to 17.5 is 2.5. From 17.5 to 20 is 2.5. From 20 to 25 is 5. 25 to 40 is 15. The information that we know is the frequency for the first one. So you have to times by a frequency density of 2 to get 20. For the next one we know we need 30, and we want to times something by 2.5. So you can do 30 divided by 2.5, which is going to give you 12. Next one, we want 40, and it's 2.5 times something again. So 40 divided by 2.5 is 16. Now we need the info from the table to figure out our scale. So the first one goes up to 2. I should have given myself more space here. So that's 2. So 2 little squares is 1 up. Okay, so 2, 3, 4, 5, 10. Let's label on the key ones. 20, 30. Okay, which is frequency density. That would do. So the next one that we want info about is the 10 to 15. So 10 to 15 is 5 across, and it's up here. Let's figure out how much that is. So 2, 4, 6, 8. Okay, so it's 8 high. So that means that we can fill in the frequency density of 8 and do 5 times 8 for the area, and hence for the frequency, which is 40. Okay, next 2 are done. 20 to 25 here. So 20 to 25, we want to know how high up it is, and it's here on the scale, which is 4. So 4 is your frequency density, and 5 times 4 gives you 20 for how many people. Next one, 25 to 40, quite a large one. Well, long anyway. 25 to 40, so it's going to be 15 across, as we talked about. This goes up to literally just 1. Okay, so it's 1 there. 15 times 1, that just represents 15 people. So we filled in the table, and we need to fill in the histogram. We actually did B before A, but who cares? So 15 to 17.5, you need to go halfway in the middle. 17.5, and you need to go up to a frequency density of 12. So remember, we figured out the scale. So this is going to be 12 here. Dear, what's that? Okay, there you go. Is that one done? And for the next one, we need to go up to 17.5 to 20. So it's here. And we need to go up to 16. So 12. You know what? What have I done here? Don't tell me I messed up my scale. Guys, so sorry about that. That isn't 10, 20 at all. That's 15, 20. My mistake there. Okay. So, 10, 12, 14, just about. Oh, these lines are really confusing me. So each little one is 1. So 10, 11, 12, 13, 14, 15, 16. Sorry about that. Little mess up. Here. Finally got it. It's a lot clearer if you've actually got it on paper, to be fair, so you can see what's going on. So we've completed the histogram, we've completed the table. Okay, now we're going to look at the second part of this, which is to do with children connecting to the internet. So this tells you information about how long it took children to connect to the internet. None of the children took more than 40 seconds. Okay, I'm just going to draw the lines on again because it is really not clear here. It's gone a bit high. Start again. Draw the lines on as neat as I can. Okay, so that's the information given. 110 children took up to 12.5 seconds. Okay, so where's 12.5? It's between 10 and 15. So whatever area it is, less than that, that's the cutoff point. So we're talking about this area. That is 110 people. Okay. Part C, work out an estimate for the number of children who took 21 seconds or more. So 21, again, this is literally testing my eyes here. 2. We want to estimate how many people are up here. Okay, so let's get on with the job at hand. Can you see how many squares are here? We're going back to primary school here. Got 1, 2, 3, 4, 5, 6, 7, 8. And then there's these slithers here, look. 1, 2, 3, 4 slithers. So it's 8 full squares. And then I'd say each of these 4 slivers is a quarter. So it's 9 squares altogether. So 110 is 9 squares. Very primary school maths, I know, but it'll do the job. Let's see how many squares we've got in total for the over 21. It won't be perfect because of the nature of trying to do it on the screen and not really seeing what's going on. I feel like I'm stabbing in the dark half the time here. So that is 0.4, 0.8, 1.2, 1.4, 0.4, 0.8, 1.2, 1.6, 2, 2 and a bit, 2.4 let's say. It is only an estimate. Plus another one whole. They're 2 halves making up 3 more. And then that looks like about 0.6. So 1, 2, 3, 0.6 is going to give you 6 squares that we want to know about. This really is taking the definition of estimate to the extreme. We know 9 squares, we want 6 squares, so you can divide by 3 from 9 to get 3 and then times by 2. 110 divided by 3 on the calculator is 36.6. Times it by 3, not times it by 3, times it by 2 is going to give you 73.3, but it's just an estimate, 73. Hopefully I've just shown you the idea of how to do this type of question. You find out a key about how much area something represents, and then you can apply that to a different situation. Right, I think I owe you guys an apology for this video being a little bit shabby. My only excuse that I can give you is my eyes are blurring looking at these crosses, and it's very hard to count on the board, I'm afraid. But it's no excuse. You guys deserve better. Anyway, hope this has helped if you did need help on histograms, and hope you're feeling confident about your maths work. I wish you best.